Hi everyone. Today we'll look at rotting oranges problem. We are given a matrix of both rotten as well as fresh oranges and some empty spaces. So each minute a rotten orange will also rot its neighbors. So this is minute 0, we start with one rotten orange. In minute 1, its neighbors, the right and the bottom orange are rotted. In the minute 2, these oranges that are neighbors of the newly rotten oranges are also rotten. So this keeps going till all oranges are rotten. We are supposed to return whatever is the minute when all oranges are rotten. This is minute 0, 1, 2, 3 up to 4. So we return the answer 4. We also have an example. Let's show it visually, right? So have an example where an orange cannot be rotten. So this does not have neighbors and it's a fresh orange. This means we have to return the answer as -1. Okay. So we'll go into the simulation. What we'll do is we will do a breadth first search and we will have a DQ to do the breadth first search. So this first box represents whatever is the popped element that is being processed. These two boxes represent two sections of the same DQ. So we'll get into the program. So what we'll do is, in the very first thing to do is place all the rotten oranges in the DQ and then get into this loop. Okay, so this is the only rotten orange, so that's the only element in the DQ. So we pop that element and then look for its neighbors. So we are at minute 0 now. Okay, we look at its neighbors and we add those neighbors to the DQ. So once the first section is all popped out, then we go to the next part of the loop. We go to the next iteration of the loop and we increase minute to the next minute. Now it's 0 and we have another section. The queue is not empty, which means we will increase minute by +1 and then start popping these newly rotten oranges and see if they have any fresh neighbors. Okay, this is the first newly rotten orange. We pop it out. We see if it has any fresh neighbors. It has this one. So we add it to the DQ. Again, there is another neighbor. We add that to the DQ. So this is one of the newly popped oranges, rotten oranges. And we popped it and processed its two neighbors. Now, the other one is this one. We'll process that as well. We pop it out of the first part of the DQ. See if it has any new fresh neighbors. It doesn't. So we pop, we go to the next section of next minute because we do have elements in the DQ still. So we increase minute by 1. Minute 2, we see if these two newly rotten oranges have any fresh oranges. This one does not have any. The other one does have one at the bottom. We put that to the DQ. And then since the DQ is not empty, we increase it by 1 more minute. See if there are any new neighbors. We have 1. So we increase it by 1 minute. So we are at minute 4 and this one does not have any fresh neighbors. So the answer is 4. So let's get into the code now. So in the code, we initialize a double-ended queue and we traverse over each and every cell in the matrix. And if we find a rotten orange, we append it to the double-ended queue. And if we find a fresh orange, we keep track of the total count using this fresh variable. Because in the end, if we are not able to reach any of the fresh oranges, we have to return -1. That is why we bookkeep this. Now we start at minute 0. And if there are any rotten oranges, we go into the double-ended queue, we go into the iteration, and we pop the rotten orange, one rotten orange at a time. We pop one, and then go in all 4 directions. In any of those directions, if we find a fresh orange, we append it to the queue. So that will be the next part of the queue. Right? So because we are looking at the length at the very beginning of the iteration, and we are only looking at the first part, traversing the first part, right? So this is the first part of the double-ended queue, and we will traverse only that. And if there are more unrotten oranges that are found, we will append it to the queue, but we won't process it in this iteration, right? We will process it in the next iteration. Okay, so we add all the new fresh oranges to the queue, increase the minute by 1, which means now the newly added fresh oranges are actually rotten. So we go see if there are any in the queue, then we go to pop each and every rotten orange from the newly made queue, I mean the new part of the queue, see if there are any neighbors. We keep doing this until there are no more rotten oranges or fresh oranges that can rot that are affected. So these minutes will track exactly how much time it took for the rotten oranges to reach everywhere it can. So we return these minutes if there are no fresh oranges left. If there are unreachable fresh oranges like this one, then we'll return -1. Otherwise, we'll return minutes. Hope this was helpful. You can try out these, visualizations in happme.dev. See you in the next video. Thank you.